So if one were to employ either what is called a solar geoengineering or a solar radiation management climate engineering technique, you have a way in which it may be possible to reduce the temperature of the planet, but that doesn't affect the amount of greenhouse gases, carbon dioxide, in the atmosphere. And what happens is that if there is a sudden cessation of such a deployment of climate engineering, then the level of CO2 is still higher than may be safe. And whilst you are deploying the solar radiation management, you suppress the temperature. As soon as you stop, the temperature bounces back up to what it would have been at that higher level of carbon dioxide in the atmosphere. And so you get this sudden jump in temperature if one were to suddenly cease the deployment of solar geoengineering. And that's called the termination effect. So if the termination effect were to happen, if there was a sudden cessation of solar radiation management, you would get this uplift in temperature, which would be sudden. And there's been some modeling studies that indicate that you could expect temperature rise at the rate of 1.2 degrees centigrade per decade, which is far faster than is currently being experienced through the climate change that we're experiencing. And that's a global mean. And in high polar regions, you might expect a rate of temperature change 3 times that. And that's an extremely fast rate of temperature change. So you get very rapid temperature change, and that would have effects on the hydrological cycle. So you would get changes in rainfall patterns around the world caused by that, very, very rapid changes. And that would obviously have knock-on effects for agricultural productivity. So that's the kind of physical effect. But then there's also the social effect as well. Because if there was a long-term deployment of solar radiation management and you were able to stabilize the temperature for a good period of time, there may be not the investment into adaptation that is required. And then if you get a sudden increase in temperature, you haven't got time to adapt. Also, the rate at which biological systems could adapt would be very short. And biological systems already struggle to adapt to the slower rate of increase of climate change. They would struggle even more to adapt to the faster rate of the termination effect. So the best way to avoid the risks of the termination effect are to, at the same time as deploying an SRM technique, is also to deploy a technique that takes greenhouse gases out of the atmosphere. And then in that way, if you were to suddenly cease SRM, then you wouldn't get this rebound effect. Even a partial deployment of carbon dioxide removal techniques would suppress the amount of termination effect that you get. The second way is to look at the rate at which you terminate. So if you had a very sudden cessation, you would get a very sudden termination effect. So it would be important, if you were to go into SRM, to have adequate mechanisms so that you understood how you would exit it. Because if you wanted to exit it, you'd want to do it at a slow rate so that you stretch that termination effect over a longer period of time. And that would be helpful. It's really important not just to think about the effects of solar radiation management when they're happening. You also have to think about what happens when you stop taking it. So it's a bit like thinking about the use of a drug. You think about the side effects of the drug when you're using it, but you also have to think about what happens when you stop using that drug, the withdrawal effects. And then the third thing is you could avoid the termination effect simply by not deploying solar radiation management. And if you consider the termination effect to be such a severe danger that you want to avoid it at all costs, then that would say that you want to avoid deploying SRM in the first place. You really need to think about your exit strategy. If you haven't got an exit strategy, you haven't really got a strategy.